Good morning, Professor. This is Sai Krishna Possibility. Now we are going to give a presentation about the research paper, and these are our teammates Siddhartha Kapatti and Vamshi Javaji. Next slide, please. Yeah, the paper is about risk assessment of additional works in a railway construction investments using the base network, and it was proposed by these two men. And next slide, please. Coming to the brief overview of this paper was developed for the sustainable development goals of the railway infrastructure projects. So because the railways have to be used by the current generation people and the upcoming generations as well, that is what meant by the sustainable development. But there are several lot of risks involved in the development of railways infrastructure. There are additional tasks that are to be performed and which involves the many of the risks. So by using an algorithm, by using a base network, we can assess the risk assessment. So this is what all the brief about this paper. The execution of expensive framework development ventures in concurring to the sustainable development objectives could be a complex and of compromising numerous stages. So as we have discussed above, discussed earlier, there are a number of stages and a number of additional tasks that has to be performed. So coming to the Bayesian network. What is Bayesian network? So Bayesian networks are widely used as a class of probabilistic graphical models. Bayesian networks are flexible, interpretable, and compact representation of joint probability distributions. So Bayesian networks generally uses joint probability distributions like P of A by B, P of A, B by A. So all these one. So general Bayes network is defined as P of A by B is equal to P of B by A into P of A by P of B. So this can be general Bayes rule. This is known as general Bayes rule. The Bayes network in AI can be used to create models from data and expert opinions, and it has two sections: conditional probabilities and a directed acyclic graph. So the parameters include a limited cycle of probabilities for each node. As we have mentioned, the network consists of a node. So the probability, each node has certain probability in it. A structure is a directed acyclic graph that conveys conditional dependencies and independence between the any element of the node. So next slide, please. So the process of assessing and implementing ways to limit the impact of danger on the construction project is called the construction risk management. So as we have discussed, the risk management, the risk assessment and the risk management are both the parts of developing the railways infrastructure and the agenda of this project. So this is what we call as an risk management. The risk management process includes extensive planning to develop risk management strategies and help project managers identify, monitor, mitigate the risks that occur. So risk occurring to the courses of action of the ISO standards. There will be some standards set by the international organization called ISO. So we have to maintain and we have to reach that to that level. So probability equation. So the general probability equation in which we use is defined by R is equal to F of P comma C. R is known as risk. P is the probability of event which will occur, and C is the impact of event of probability on the eventual conclusion. As we have discussed, we are considering probabilities in this to solve this problem and developing an algorithm using probabilities. So here P is equal to the probability of event which occurs, and C is the impact of event on which the project's evaluation occurs. So next slide, please. Yeah, so this is the ISO risk management process, and let me define the terms in it. So risk identification. So first, risk identification is the method of recognizing things that can avoid you from accomplishing your goals. So basically, to develop an infrastructure of the railway, we will be having certain goals to maintain and to improve the standards of it. So the first thing is we have to identify the certain things that impact our goals. So it is generally called as an risk identification. So next thing comes under risk analysis. It incorporates distinguishing the causes and the causes of recognized risks to recognize remaining risks, as well as surveying the probability and result of event within the light of existing controls. So this is commonly called as risk analysis. And after risk analysis, then we have to evaluate the risk. So that is commonly called as risk evaluation. And the risk evaluation comes about the risk analysis to the risk criteria to decide on the off chance the remaining risk is worthy or not. So, and next comes the under the treatment, which is known as a risk treatment. So changing the sum and likelihood of both positive and negative impacts to create a net increment in the profit. So this is known as risk treatment. Let me really quickly discuss about the process. Vamsi, can you slide down the... So establishing the context. So this is the process: establishing the context, risk identification, risk analysis, risk evaluation, and the risk treatment. So establishing the context, characterizing the scope of risk management process, characterizing the organizational objectives, setting risk assessment criteria, all the exercises not specified in the past dialogues of the risk management process. So next goes to monitoring and review. The this action includes comparing risk management execution with indicators that are assessed on standard premise to guarantee that they are still relevant. So next comes under communication and consultation. This movement helps to get into interface and concerns of partners and guarantees that the risk management process centers on the pertinent parts and clarifies the method of reasoning for the risk handling choices and options. So next slide, please. So now let us discuss the model for risk assessment, which is known as risk assessment method framework. According to the standard recommendations, risk assessment is divided into the stages, as we have discussed: risk evaluation, risk identification, and risk analysis. So the risk identification, structured or semi-structured interviews; risk analysis, based on statistics and based on nets; and risk evaluation. This is known as probabilities. Uh, Consequence or probability matrix. We use consequence or probability matrix for that. Uh, Master data accumulated through organized or semi-structured interviews was utilized to arch input information on the subject, which was combined by the display state of information with respect to the additional works in the railway road speculations. The information will be encouraged, analyzed using the Bayes and networks, which permit for modeling with the tall vulnerability on the premise of cause and impact thinking. The consequence slash probability network will be utilized to the survey risk, which occurring to creators permits us to clearly build up the level of risk and carry out exercises focused on at moderating it. So as we have discussed, Bayes and networks will be very, very useful in for the modeling with the vulnerability, and probability network will be utilized to the survey risk. So to assess the risk, the probability networks will be useful as well. The risk assessment stages and tactics used for additional work on the road development are dissipated in the diagram above. So this is the diagram which we have given above. So next slide, please. So the risk identification, risk factors for additional works. There are types of additional works occurring, time periods for the extension of construction works, and the result of additional works. Amounts in the increase of financial resources is also comes under the additional works. So identification of the risk of the additional works in the railway projects. When we are talking about particularly the railway projects, we have these type of risks. The others prepared a questionnaire with questions that allow for the identification of most important parameters describing emerging additional works in the railway infrastructure construction investments in Poland. So this is an example we can consider in this paper, specifying factors initiating the creation of additional works in the railway infrastructure construction investments and indicate the probability of their occurrence. Specify the types of construction works that occur with the occurrence of additional works in railway infrastructure construction investments and indicate the probability of their occurrence as well. Specifying the 3 time periods in a month and which likely and most likely date for extending the duration of the railway infrastructure construction project as a result of additional works and specify the probability of their occurrence. So specifying the 3 amount ranges, which are most likely to increase the financial resources that the investor must obtain for the implementation of railway infrastructure construction project as a result of additional works, and specify the probability of their occurrence as well. So next slide, please. So risk identification for additional works results. So the risk factors for the additional works: delaying the supplies of building materials and the products to the bad organization of work, unrevealed elements of underground infrastructure, incomplete geological and engineering recognition of the construction, changes in the uh, design solutions introduced by the employer, substantial development, substantial errors and incompleteness of the project documentation, failure to provide track closures. This all comes under the risk factors for additional works. Direct interviews were conducted with 5 participants of construction process to deal with the construction of railway infrastructure in Poland. So people from large construction companies with relevant experience, seniority, practice in managing the implementation of such investments were selected for the study as well. The respondents were also asked to assign a probability of occurrence expressed in percentage to the answer given. And the next slides will be continued by our teammate Vamshi Javaji.
Yeah. Hi, yeah. Grouping of elements consisting the factors of the risk identification factors. Like there are risks, there are appearance of additional works like delaying the supply of building material and products, bad organization of works, elements of underground infrastructure not disclosed on available maps of the construction site, incomplete geological recognition of construction site, changes in design solution introduced by the investor during the implementation of the investment, substantive errors and the incompleteness of the project documentation, not guaranteeing track closures despite the fulfillment of contractual conditions, and implementations of problem of neighboring projects. These are some of the risks in accordance to the appearance of the additional works. And some of the types of additional works in the risks are tracks and drainage works, network works, engineering object works, road works and railroad crossings, platform building works, works related to the reconstruction of water and sewage, gas and energy networks, preparation of project documentation, other works, and works related to the reconstruction of railway traffic control devices. These answers are given by the respondents were grouped according to the proposed scheme. As a result, 3 groups were obtained. The risk group was divided to risks related to the appearance of additional work and risks related to the occurrence of the individual types of additional work. These are the elements regarding the constituting the factors of the risk identification process. Coming to the next slide, this is about the risk analysis selection of factors. They are bad organization of work, change in the design solution introduced by the investment during the implementation of the investment. Like changing the design in the middle, first they will think some plan, some architecture. After going to the middle of something, they will change the plan. It will is the risk for the. It will be definitely a risk for the project. And substantive errors and incompletion of project documentation, like and track and drainage works, network works, engineering object works, railroads crossings, extension of the implementation duration as a result of additional work. The project manager will extend the days of the work, so it will be definitely a risk factor. Based on these results of the research, the author shows the factors that the probability of occurrence was not highly rated by the participants in the construction of the risk assessment model for additional work. The direction of factors used to build the proposed risk assessment model is discussed above now. So we have introduced the Bayes network method. Firstly, what is Bayes? Bayes is nothing but a mathematical theorem implemented by British mathematician Thomas Bayes. This theorem is nothing but a mathematical formula for determining conditional probability. This conditional probability is nothing but the likelihood of outcome occurring based on the previous outcome occurred in the similar circumstances. In real time, this Bayes theorem often employed in finance sector in calculating and updating the risk evaluation. So this theorem will really play a vital role for calculating the risk analysis factors. So this theorem has become a useful element in the implementation of machine learning and artificial intelligence too in the real world. So this is a Bayes network method, like creation of nodes of the Bayes network, giving relationship to the nodes, assigning event probabilities, and performing calculations. For risk modeling, the Bayes network method was chosen, which seems to be the most appropriate for the problem in this question because it is based on the probability of the events and allows the introduction of the new information to the model using expert knowledge or historical data. Risk analysis was mainly carried out in 4 stages based on the Bayesian network design. They are creation of the nodes of the Bayes network, driven relationship between the nodes, and assigning event probabilities and performing calculations. By these 4 stages, we can calculate the risk analysis factor. Coming to the creation, how we will create the nodes in this risk analysis factor. Suppose, for example, bad organization of work and possible scenario considerations. We have taken one of the risk analysis factor and trying to analyze. It occurs 67%, bad organization of work does not occur 33%. These selected risk factors, the possibility of additional works, like after going into the middle of the work, we came to know the probability that the work will be done or not done. So they will calculate based on this. They have taken the bad organization of work as an example. Type of additional work and the consequences of this phenomenon were used to create the nodes of the Bayes network. As an example of node describing the event of appearance of organization of work together with the possible scenarios of the risk assessment part is shown below. Risk analysis weight model to assess the assessment of additional works, like bad organized, same as the diagram above. These are the factors, but the uniqueness of this studied problem required the creation of indirect event in the form of Bayes network in the form the additional work node. The node was proposed as separate because an important context of the work is to determine the occurrence or absence of additional works. This event was modeled by connecting the nodes consisting the risk factors, changes by the investor, error of the project documentation, effectiveness of the appearance of the works in the form of types of industry works, track works, engineering object works, road works, and network works. Coming to the risk analysis, assigning event probabilities, errors of project documentation by facility or correct, changes by the investigator make changes, bad organization of work, and the occurrence probability, and the does not occur probability. The correct functioning of this model requires assigning each event the probability of its occurrence. The Bayes network is characterized by the fact that the events of the initiating nodes are introduced directly by determining the probability level. This requires the authors to analyze all possible combinations of consecutive events and determine their probabilities. For this purpose, there is called conditional probability table. This table is shown how we will divide the bad work organization of work, event that occurs and event that do not occurs. This is the table. Coming to the risk analysis performing calculation, how we will calculate Bayes theorem. Its formula is nothing but P of A by B equal to P of B by A into P of A by P of B. The conditional probability theorem P of A by B equal to P of A intersection B by P of B. These are the formulas which are used for the calculations in the Bayes theorem. By using the risk analysis factors, we can calculate by taking the probabilities of occurring and not occurring as A, like not occurring as B, and we can calculate this, and we will get the calculation of risk analysis performing calculation. The basic relationship used in the construction of the Bayes network theorem of Thomas Bayes, finding the conditional probability of 2 events, conditioning each other. Applying this theorem, a series of events allow us to determine the probabilities of all events forming the network. The Bayes theorem. In here, A and B are nothing but the events. If P of B greater than 0, P of A by B is the probability of event A occurring if the B event B occurs, and P of B by A is the probability of event B to the occurring if event A occurs. Conditional probability theorem, where A and B are events and B of B greater than 0, then P of A by B here is the probability of A occurring if the event B occurs, and P of A intersection B is nothing but the probability of the common part of for event A and event B. These are the formulas for the calculations of the factors. And after preparing the model and creating working Bayes network, calculations were carried out. And how the calculations will be done is shown in this figure, how we can calculate risk evaluation, building a risk assessment matrix, event frequency, rare, unlikely, possible, likely. and the probability percentage like rare 0 to 20%, unlikely 20 to 40%, possible 40 to 60%, likely 60 to 80%, almost certain 80 to 10%. The 5 intervals matching to the anticipated probability levels were offered for the event probability, while 3 intervals related to the occurrence that result in a longer implementation time were recommended for event impacts. And the risk level like low, medium, and high, and very high. And if it is low, the risk acceptance, no major credible action, and it's medium. The what if based on the risk, we can take the action and we can decide the point range. If it is low, from 2 to 6. If it is medium, the risk tolerance we can avoid. If it's high, we have to take the action immediately. Based on that, we can arrange the point range. The insertion of the performed risk criteria and impact of the risk in the matrix is required for risk assessment. Point value and color were used to define the individual matrix cells. According to the danger level, the who was chosen as follows. Blue indicates a low danger level, like level of risk. Medium green, yellow indicates a high danger level. Red indicates very high risk level. When the Bayes network is applied to the problem at hand, it's possible to take advantage of the mathematical methods unique capabilities in the form and event scenario analysis. Additional changes based on the relationship of the original model can be developed. In addition to the base event probability predicted on the bias of the study, individual variations are constructed by defining conditional probabilities for the nodes that have been chosen. Different levels of event detail can be analyzed, but the authors believe that declaring probability as 0 or 100% best dissipates the event that are feasible. And my friend Sidhu will explain from here.
Thank you, Vamshi. Here I'm going to explain the network is affected while modeling the occurrence of an event. The author selected to investigate the impact shown in the node extension of time because the phenomena may be researched in response to a variety of variables. The probability came from the node extension of implementation time, extending the implementation period to 3 months, increasing the implementation period from 3 to 6 months, extending the implementation period to 6 months. According to the adoption of the proposed risk assessment technique, a low level of risk may be accepted by the investor, but a high level of risk should be further analyzed for this, resulting in the removal of additional expansion of the investment term. Next slide, please. Here comes the risk mitigation proposal. The optimal risk management plan is determined by a number of criteria. Example, a list of risk hierarchies, the likelihood of the meeting cost and the schedule goals, a list of variable ways of action, and so on, and involves a reaction to each type of risk encountered in the project. The action plan is chosen in order to maximize the effectiveness of the actions conducted. The most popular strategies include risk avoidance, risk transfer, risk mitigation, risk acceptance, emergency plan. The instance of inaccuracy in project documentation, as described above, creates a high-risk situation. Inacceptance is not desired based on the premises. Furthermore, based on the finding, it is reasonable to conclude that the risk will not be mitigated. As a result, the author chose one approach of the risk reduction that appears to be implementable in the process of railway investment implementation. Among the 3 options of big firm, risk transfer, risk mitigation, and the contingency plan, risk mitigation is a method of lowering the probability or severity of the negative risk occurrence to a manageable level, reduce the change of inaccurate documentation, or shorten the implementation time. According to this definition, it was thought that reducing the risk of inaccurate paperwork as a result of various investors' actions would be more practicable. Checking documentation supplied by a different design firm, consulting industry experts, or using standard catalog solution are all examples of method. It was assumed regardless of the method used. Here comes the summary and conclusion. The author described one of the methods for developing management plan based on a standard methodology that compares the risk identification, risk analysis, and risk evaluation. The chosen case includes a unique technique based on the bias network. These approaches may be used to simulate complicated effects network using servers, historical data, or expert views. A well-programmed network may be used to deploy risk mitigation measures and evaluate their influence on other network nodes. As demonstrated in the mentioned event scenario, mitigates are measured that lower the likelihood of a risk factor occurring. These networks may be used to investigate the impact of specific event scenario. The user may evaluate alternative approaches to describe risk, examine the influence of the variables, generating extra work on the other top of the network, or decides a sufficient level of effects, such as a growth in the worth of financial research because of the new work by utilizing the network. The suggested model is a simplified version of the author's bias network, which will be used to investigate other components and the consequences of the greater job risk. The authors also want to use new data gleaned from expert view or past data to conduct network learning. Here comes the references. Thank you.
Thank you.
Thank you.